Section 1.1, Inequalities and absolute values. The real number line can be divided into intervals. The intervals can be either open or closed. For example, if you have a line, then this thing is called an open interval because it does not include endpoints. Or you can also have a closed interval where it does include endpoints. The description of that is sometimes called x between a and b, whereas this is called x is less than equal to, bigger than equal to a and less than equal to b. And of course, the intervals doesn't have to have two ends. Sometimes you can have an interval that goes unlimitedly in that direction, and when that happens, we call it minus infinity to say this point is b to b. The infinity is not a number. It's very important to remember that. It merely indicates that you go on in the number line and doesn't ever stop. Because if you stop somewhere, that's a fixed number. It's not infinity, no matter how big it is. Now, the next thing we want to talk about is inequalities. The inequalities has a specific, it has similar qualities as just regular equalities, with a very distinctive difference in that when you multiply an inequality by something, say you have AC, that is only going to be less than BC if C is positive. If C is negative, then the opposite is true. That is, you have to, then it becomes BC is less than AC, given that A less than B, if C is negative. Because a negative number multiply a bigger positive number make it even more negative. So then the inequality or the position becomes flipped. Now let's look at an example of inequalities. Okay, let's do the example such as example 1. Let's do 1 over x is less than, say, 3. How would you solve an inequality like that? The answer to inequality is always come in intervals, because there's lots of stuff where that will suit x, where the whole thing will come out to be less than 3. It's not just one number. And you have to collect every single thing, which means whenever you do an inequality, you have to consider the entire number line, which part of it solves the inequality that is fit its description and which part doesn't, and present the whole thing that way. Okay. So to solve this inequality, we'll multiply both sides by x. So then you have, and divide by 3. So then you have this, x. But be very careful that this is only true if x is bigger than 0. As we've mentioned, that if it's bigger than 0, the inequality holds when you multiply or divide. If it isn't bigger than 0, then you got a problem. So right now, we'll only check the part that x is bigger than 0. You always have to check, well, parts of it at a time. Now, if that's true, then you calculated that x is bigger than 1/3. So bigger than 0, bigger than 1/3. The conclusion then is x is bigger than 1/3 is one of your answers. Okay, that's one part of the answer. But you're not done yet because we've only considered x bigger than 0. What happens when x is less than 0? If x is less than 0, then what? Then 1 over x is going to be less than 0 too, because it's negative, okay? So therefore, which means it's going to be less than 3. Therefore, x less than 0 is the other part of the answer. So we have two parts, bigger than 1/3 and less than 0. Those are your only solutions. X cannot be 0 because then the fraction will be not defined. So these two together will be the complete answer of the inequality 1 over x less than 3. Now, generally inequalities are kind of cumbersome to do. It's tedious. You have to consider each parts, especially with fractions, and you have a lot to think about. But if you go about it systematically, you can always get to the answer. Now, the next thing we're going to talk about is absolute values. The absolute value, as you have learned in the past, it just means, let's say, if you have the absolute value of A, okay, that just equals to A if A is positive, or it equals negative A if A is negative. That just means you take the positive value of whatever that is. That is the definition. Because if A is negative, another negative sign will make it positive. So the absolute value of A is just its own value, whatever that might be. Now the absolute value has certain qualities, and here's one of the more useful qualities. Okay, to show, let's look at one of the qualities, which states that the absolute value of two numbers that you add up, A plus B, is going to be less than or equal to the absolute value of A plus absolute value of B. And now let's prove that. Now the way you prove that is you go about like this. First you look at the A as given the absolute value of A is going to be bigger than or equal to A itself, right? And similarly, is also going to be bigger than or equal to the negative value of A. Well, that is by the definition. In other words, it's just this distance from the origin. So either equal to it or is, if it's negative, then it's definitely bigger. If it's positive, it's the same. So it's the same or definitely bigger. And then the next thing, we'll do the same thing with B, so that we'll have B is less than absolute value of B. And is also less than or equal to the minus B. That's just the definition right here. So then if you add this stuff up, what that means is you add it across here. So then we have, from the first line, we have absolute value of A plus B is bigger than or equal to just A plus B. We're adding up the first two inequalities. And similarly, if you add up the second two inequalities, I said that wrong. This is A plus B. See, we're adding up the right side here. So it's A plus B. And then similarly, if you add this one up, so this is A plus B again, is bigger than negative A plus B. That is, I add that to that. Now these two inequalities together says the same thing as this, because this value is either that or that. So these two inequalities prove what we were trying to prove in the beginning, and it comes out very nicely. In the next video, I'm going to present some of the more challenging problems in this section.